Hey guys, we are still in chapter 0 and we're looking at a really short video right now on surface area. So let's get started. Surface area is defined, and I won't even write up the definition, but this is the only new term that we have in this section. Surface area is defined as the area of the surface of an object, okay? So I have this jar, and if I wanted to calculate the surface area, sometimes I think about surface area as wrapping a gift, like how much wrapping paper you would need to totally cover the area of the outside area. So you're not measuring volume, you're not measuring like the two-dimensional area, you're measuring the area of all sides of an object. So we'll do cylinders, which this is, and we'll also talk about rectangular prisms, which this is. All right, so let's take a look at an example. So here we have a cylinder and we have a rectangular prism, and I think I put them in the wrong place, so I'm going to just erase that and pretend that didn't exist. La la la. That one was the cylinder. You got it. Okay, so we've got a cylinder. We need to think about how we can find the surface area of a cylinder. Well, first of all, let's think about what a cylinder is comprised of. We have the top part right here, which is the top circular portion, and then we've got, which we can't see, but kind of a bottom circular portion that would be inside. And then of course we've got the sides of the thing, which is all here, all the way around. And so what we need to kind of do is think about what makes up the cylinder, what makes up the outside of the cylinder. So I know I've got two circles, right, top and bottom. And then what about the sides? How can you describe the sides? When you think about the sides, I want you to recognize that, let me pick up my cylinder again, that just like when people make labels for around a cylinder can or something like that, if you were to rip off that label, what shape is it? It's a rectangle. So honestly, when we talk about the surface area of a cylinder, we're talking about the area of the top, the area of the bottom, and the rectangle that is, in a sense, bowed around to create the actual body of the cylinder. So here's the deal. We need to think about the dimensions of the cylinder. Now, you guys are pretty cool. You guys have gotten over the shock and horror of finding the area of a circle, right? So we know the area of the circle is pi r squared. So we're going to have that times 2. Right? Because we've got two circles of the same area if we have a normal cylinder, and that's cool. The next piece we have to think about is that rectangle. So the rectangle in the center, I'm going to draw it like this, and I'll highlight it in purple. We know a little bit about it, right? The one thing we do know about that rectangle is that it has a height of 5 feet, okay? So that part is given, and I'm going to jot that down right now. So the height is 5 feet. I got that part, 5 feet. Now the thing I need to figure out is the width. Remember, as with a label, if this label doesn't touch, but if the label were to go all the way around and touch, what would be the length of the label? I'm hoping right now your mind is bubbling and you're saying, it's just the circumference of the circle. And you got it right. So to find this part here, we would need the circumference of the circle, which we know as pi d, or 2 pi r. I'm going to write it as 2 pi r right there. So now if I can find the area of this and then the area of the circle and multiply it by 2, I'm going to add all that up together, and what I'm going to get is the surface area of that cylinder. Let's try to do that. So here's a quick visual recap. I'm going to find the area here of the purple by doing 2 times pi times r times 5, so base times height. And then I'm going to find the area of the circle at the top, and I'm going to multiply it by 2 because I've got 2 of them. And I'm going to add all that information together. So here's what we've got. Slide down one more time. So 2 pi r is going to be 2 times pi times 2 again, because that's the radius, times 5. So that takes care of my rectangle. So now to that I'm going to add the 2 circles, and the circle is pi r squared, so that's pi times 4, because r is 2, and squaring that I get 4. So now all I have to do is do the math and see what I get. So 2 times 2 times 5 is going to give me 20 pi, right, because that's pi there, plus 2 times 4 times pi, which gives me 8 pi. So my answer is 28 pi, which probably comes to something like about 25 point something. I'm going to check my calculator really quick, and get that answer. Okay, I don't know what I was just talking about there. I said 25 something. I think I was thinking 8 times 3.14 and not 28, but it's 87.92, which sounds far more reasonable. And that would be, since we're talking about area and not volume, that's going to be feet squared, because those are the units that we're using. When I look up here, it says round to the nearest tenth. So I'm going to come back down here and just leave my final answer as 87.9 feet squared. All right, let's go ahead and take a look at this prism. I think the prism you guys felt really much more comfortable with. What I like to look at is the fact that we have corresponding faces, like this face and this face has the same dimensions. So when I think about this, I know that I'm going to be able to use some of that information for my benefit. The bottom and the top have the same dimensions, and let's see if this is going to come out clearly. And the left side and the right side have the same dimensions. And I know that became gobbledygook, but I hope it made sense as we were thinking through it. So let's just take a look. So I know I'm going to do 2 times 4 times 5, right? Because that's going to give me the base and the ceiling of that particular prism, rectangular prism. And then I'm going to do, let's say, 4 times 6. That'll give me the front and the back. Twice, 2 times 4 times 6. And then the next thing I'm going to do to get the sides, I'm going to do 2 times 6 times 5. So that's going to add 2 times 6 times 5. And this should be pretty simple. Here I'm going to get 40 plus 24 times 2, I'm going to get 48. And here I'm going to get 30 times 2, which is going to be 60. And when I add all of this together, I get 148 centimeters. And again, this is not cubed, even though we're dealing with a 3-dimensional figure. We're talking about the surface area, and area is a squared unit. All right, so I hope that made sense, and I look forward to talking to you guys more about this in class. Take it easy.